Let's look at the last example. A city's annual rainfall approximately normally distributed, so I know it's going to look something like this. And the mean rainfall is 40 inches. I'm going to put that in the middle. It says that 1 standard deviation is 6 inches of rain. So I'm going to go 1 standard deviation away and add 6. And then go on the other side 1 standard deviation and subtract 6. So 68% of my data should fall within that range. Let's go another standard deviation on each side. So I'm going to add 6 to this one, get 52, subtract 6 from this one and get 28. And now I'm up to 95% of the data, so that adds another 13.5 or 0.135 on each side. And then another 6 inches and another 6 inches would put us at, so this was 1 standard deviation, 2 standard deviations, so now I'm at 3 standard deviations away. So another 6 added on to the end would put me at 58, and subtract 6 here would put me at 22. So I've got 0.0235, 0.0235 on each side, and then I have my outliers on each end of 0.0015, 0.0015. So now I want to try to answer these questions down here at the bottom. Find what are we trying to do here? Probability. So our answer is going to be a decimal. Find the probability that it's less than 34. So that would be all of these. So 0.135 plus 0.0235 plus 0.0015, and that would be 0.16. So that's not very likely. Okay, what about that the average rainfall is greater than 46? Well, look what happens over here. It's the same thing. We're leaving out this middle 68%, so it's going to be 0.16 also. Okay, the next one, greater than 52. So greater than 52 would be this. So I'm going to add 0.0235 and 0.0015, and I get 0.025. Okay, the next one, less than 28. That's the same thing, but on the other side. So that one's going to be 0.025. And then the last one says between 34 and 40. Between 34 and 40. So that's just 1 standard deviation away, but only on one side. So that's 0.34. And then the last one says between 34 and 46. Well, that's right in the middle here. That's 1 standard deviation on both sides. So that would be 0.68.